Hi, welcome to the session. This is ArcGIS Runtime, Tips and Best Practices for Testing Your Apps. I'm James Ballard. I'm the lead engineer for the ArcGIS Runtime SDK for Qt team. So here's the outline of what we're going to discuss today. First, we'll go over the purpose of the talk, then we'll discuss motivations for testing, then we'll go over the different types of tests that there are. Then we'll go through some demos of the Qt C++ and QML unit tests and some GUI tests. We'll discuss what those are in more detail in a moment. Finally, we'll wrap up with some advanced techniques and some best practices. The purpose of this talk is to show you the best practices that we've found over the years for testing GIS software, specifically the ArcGIS Runtime. Mainly, we want to share these so that you can be successful. If you're new to testing, it can feel overwhelming. So we hope that by sharing what works for us, it can help you. So why test? What are we trying to achieve here? We want to gauge the overall quality of the software. Software is a living thing and continually evolving and improving over time. As such, in any software system, it's important to test to make sure it is working. Without tests, how can you be sure that the software is working as intended? We also want to prevent regressions. Now, if you're new to testing, a regression is a bug that was fixed but returned at some point. It's important to have tests to make sure regressions don't come back. And lastly, we want to have confidence that new functionality going into the codebase is working and high quality. I do want to add that this is not an exhaustive list. So let's talk about the different types of tests that there are. So there are unit tests. These are short, simple, non-GUI tests. These are typically used as a smoke test to make sure basic functionality is working as designed and intended. There are GUI tests, and these are tests that display contents such as a map in 2D or a scene in 3D, which has something to be verified by some means. And I realize that by some means is a bit vague, and that is on purpose. We'll come back to that. Then there are functional or integration tests. These are longer, workflow-based tests that may or may not have a display involved. An example of this may be a test that loads a map, solves a route, and then simulates navigating that route. So as you can tell, this goes beyond just checking simple properties and encapsulates an entire workflow. Then we have image comparison tests. These are a specific type of GUI test that performs analysis on the expected outcome to be sure that you are actually getting the expected results. Finally, there are manual tests. This is where real people are using the software, pushing buttons, checking the real-world performance and usability. We do some of this and have found it's a good way to make sure the software works as intended, but it does have costs. It's labor-intensive and not scalable as the scope and functionality of the software increases. We try to limit this category as much as possible. Okay, so for the demos, I'm going to show testing with Qt C++ and the QML APIs. Many of the techniques apply to different programming languages and test frameworks. So since I work on the Qt team, I will be showing tests using the Qt testing framework for C++ and QML. Okay, so let's go ahead and get started. What we're showing here is just a very simple QML-based unit test. So we'll go one by one through the tests, and then we'll run them at the end. Let's start with test 1, a simple property. Make that a little bit bigger. There we go. So in this, it's a very simple test. All we're going to do is create a map, and then we're going to create a layer. And then we're going to add this layer to the map's operational layers. So what we're verifying in this test is that the operational layers has one object after we add it, and also the layer type of this layer is what we expect. So in this case, we're creating an OpenStreetMap layer, and we expect the layer at the index 0 to be that type. Pretty straightforward. let's go to test 2, async methods. So one of the strengths of the runtime is that it has many async operations. Loading a map is one such async operation. So in this case, this is a technique we use frequently to not have to write extensive event handling or signal handling logic in a test. What this allows us to do is create a map, load that map, and then wait for some condition to become true. Now this is important because this test method here called try compare, and this will vary from test framework to test framework, but this try compare from the QML test framework will allow us to wait for a condition. So we know that since map load is asynchronous, if we just do this here, it might not be done loading at this point, so it might not have this status of load status loaded. So what we want to do is build some resiliency into the test. So we know that this is asynchronous. It could take some amount of time. So we're going to use this method, which is try compare. Now try compare has a default timeout built in. So it's not just going to sit here and wait forever. Whatever the default timeout is, I believe it's 5 seconds for most tests. If this condition is true within that timeout, your test will pass. And this makes it very easy to test situations like this. Okay, let's move on. Test 3, async method 2. So in this test, what this is showing is a little bit of a different way to handle the same situation. So we're going to do the same thing. We're going to create a map, and we're going to, at the end, we're going to make sure that the map is loaded by checking its load status. But we're going to do it slightly differently this time. So what we're going to do is we're going to hook up to this event on the map. Now this might be called an event, it might be called a callback, or in QML you might get a signal. The terminology will change based on your programming language and the Runtime SDK that you're using, but the concept is the same. Basically, you want to handle this event and you want to get some argument that comes back. So in this case, I do realize this is a bit contrived because this test case does the same thing in less code, but for the sake of argument, we're going to go through this just to show you how you would do this. So instead of just comparing a property directly off the map, this time we're going to get the map's load status, and we're going to get that in the event itself. So we're going to hook up to the load status changed event or signal in QML, and we're going to connect this function that we're going to create here. We put it in line, and that means that we have this local object here, which is going to be the load status, and we're going to assign that from the map every time that this signal fires. We call map load, and then we wait for this. This is a little bit different than try compare in the sense that now we have a function that we're going to verify. And all this does is just a little bit of a different way to do the same thing. We're just making sure that the load status we get back from the map in the signal handler matches our expectations. Okay, now let's move on. So now we're going to get into a little bit more of some advanced techniques. So you can see now we have two things here. We have a component and we have a test that goes along with it. So in the previous tests, you probably noticed that we just create a map object using ArcGIS Runtime environment.createObject, which that works fine for very simple cases. You can see all of the tests so far have done that. Now, in our experience, where you can start to run into problems is that for longer tests where you're doing much more complicated analysis or processing, you can have long-running operations. And since QML is a garbage collected language, that means these map objects that you're creating here, there's no guarantee that they'll be destructed at the end of each test. So this can create problems. So let's say, for example, you have a test that has a map and you save a web map to a portal, and then you have another test with a geoprocessor that performs geoprocessing. And many of these asynchronous operations can be running after your test passes, depending on how you've written your tests. This can create problematic scenarios. So what we do is we use these techniques to help us control the lifetime of the objects. So create temporary object comes from the QML test framework from the Qt company, and it allows us to create a temporary object that will be guaranteed to go out of scope and destruct at the end of this test. So this does very much the same thing as the previous tests, but this allows us to control the lifetime of the map object itself. So the syntax here is just to say, I want to create a temporary object of this component, and here is the parent of this object. And in this case, this is not very important. This is just the test suite itself. So it's the same workflow again. We create a map, we load the map, and we wait for the map to be loaded. But in this case, this has the advantage of we know that this map is going to go away at the end of this scope. So if you did have longer running operations, or if a test failed and exited early, you know that that object is going to go away. All right, let's move on to the next one. Okay, now this probably looks fairly similar, but there's one key difference here. Now, in the previous one, we were hard coding the values for the map, the init URL. Now, in this one, we have an empty map. This map has no properties. Now, the advantage here is that there's an overloaded version of create temporary object, and we can pass in the properties that we want to pass to the map. Now, this is very powerful. This allows us to use this generic map object many different ways, and it allows us to have that same lifetime benefit that create temporary object gives us. So this is just a more of a generic way to use a generic component and give it properties when you call create temporary object. So again, it's just the same test code where we load a map and then we wait for its load status to be loaded. Okay, now let's move on to the next one. This is going to be a data-driven test. So let's take a look at these. There's actually two methods that go along with this one. So we'll come back to this data test, but let's look at this one here. So we have something that's called test 6, data-driven test, and it takes this data object here. Now, in all the previous tests, we create a map with an init URL, we load the map, and then we wait for it to be completed. But as you may know already, we actually support different types of URLs to initialize the map. The one we've been using so far has been the web map URL. This is the web map viewer. But we also fully support the item URL, which would look like this. We also support the data sharing URL, which would look like this one. Now we want a way to run a test without having to write that same test 3 different times. That's very inefficient. So a data-driven test allows us to test small variations and run the test repeatedly with these variations. So you can see in this one, we have a JavaScript array here, and we've got 3 objects. The tag is a special property for data-driven tests that says, what's the name of the thing we're testing? And in each case, we've given it a name. We've got the web map URL, the item URL, and the data sharing URL. And then you can make up whatever other properties you want to use. In this case, we just have one called URL, because that's the variation that we're testing. So in the data-driven test itself, we're actually going to get this data object. Oh, and I should mention that this will always have the same name, but end with _data. And in this one, we have the data object. So the only thing that's different here is that this code is the same, but this data.url is going to be each of these URLs, and it's going to be called 3 times. Now this allows us to write some generic test code and test it with very small variations. Okay, now we have some failing tests, and I will expand these, but we're not going to look at them yet. I'm going to run these tests and we're going to analyze the results. Okay, so we have our tests coming in. We have some good results coming in. Perfect. So let's take a look here. So we can see that tests 1 through 6 all passed. And for the data-driven tests, you can see we did get those variations, and it ran 3 times. So we ran it with the web map URL, the item URL, and the data sharing URL. So let's take a look at these tests with failures here. So you can see we've got some tests that failed. Now let's go analyze them. If I click this, it'll take me right to the point of the failure. And you can see that we have an expected value that we had in the test, and we have the actual value that we got during the runtime of the test. Let's take a look here. So for this, we might conclude in this test that, okay, something changed. Now let's say for this test, I go and I speak with the GIS analyst who knows all about this service that we're testing, all about this web map, And this person confirms that yes, indeed, they added a new layer, so it is expected that we should be getting 17. So we'll go ahead and fix that now. So let's go to the next one. This one, we're calling this one test 8 with unknown failure. So now, for the sake of argument, let's say we got the same situation, but we don't know what's wrong. The GIS analyst has no idea what changed, and it could be something very complicated, not something we can figure out in a short amount of time. Well, we don't want our test runs to be showing failures constantly, because failures are something that should get our attention. We should say there's a failure, we need to look into what happened. But it's just not always realistic that we can address them in a timely manner. So in this case, let's say we go to the GIS analyst and that person just says, I don't know what happened. I have no idea what's wrong. So instead of seeing this failure in the test, there's a concept in the Qt test framework, and I'm sure others as well, to say, I want to mark this test as an expected failure, which means it's failing now, but we accept that for the time being until we can follow up. So I'm going to mark it as an expect fail. I'm going to put this message in there that says it's an unknown failure, need to follow up with the GIS analyst. So let's go ahead and run these again now that I've addressed these. So the tests are running. We should get our results here. Okay, perfect. So test 7, which had the failure, we addressed. We changed it to the expected outcome. And with the unknown failure, now we have our X fail. That's what the Qt test framework calls an expected failure. Now you'll notice it says 12 passed, 0 failed. So now we've accounted for this unexpected failure here. Well, we've actually marked it as an expected failure. So we know something's wrong and we're going to address it. Okay, so let me take those out. Perfect. Okay, so the next thing I want to cover, and before I move on, I just want to add that I do have all of this logic in C++ as well for anyone who's interested, and all of these test projects will be available on GitHub after the talk. Okay, so the next one to cover is a GUI test, and for this test, I'm going to switch over to the C++ API to showcase how this works. So you have a bit of a taste of both and the techniques that can be used. Okay, so in this one, we're going to be using the Qt Widgets API, and our map test GUI test class is going to inherit from QMain window, which is a GUI-based class in Qt. Now we have a setup function that's just going to create our map graphics view, set the width and height, and set it as a central widget to display. Now let's talk very briefly about this init. Init is a special Qt testing framework method, which means at the beginning of every test, run this setup code, or run this init code. Now, we're just going to call our setup method every time. So all this does is that it's going to make sure we have a new map graphics view with a fresh state for every test that we run. Okay, so let's go into the test code. Let's look at the first one here. I'll walk through what it's doing. So like with the previous, we're going to walk through each test one by one, and then we'll run it and get the outcomes and show you what's going on. So in this case, we're going to set up our map graphics view because init's going to run first. Then we're going to set the wraparound mode to enabled. We set up a map with the streets base map, we set that on the view. Then we're going to wait for the map to load. At that point, we're going to set a viewpoint at the edge of the wraparound boundary. We're going to zoom to that point. We're going to wait for the draw status to be completed on the geo view, or in our case, the map graphics view. And at this point, this is where we could do some advanced testing analysis. We could check the pixel data on the leftmost pixels to see if we have base map with the blue ocean. Because if we have wraparound mode enabled, at this particular viewpoint, we expect there to be ocean. Now, if wraparound was disabled, we would not expect that. So I've omitted this because it adds a little bit of complexity to the test, and I want the code to be very concise. But you get the idea. We have this method on our GeoView class where you can export the image. And here's where you could do that pixel analysis. And with this one and the following tests, I've added some weights in. Now, the only reason for this is for testing purposes alone. You would not need to do this normally in your day-to-day work. This is only to allow the UI to display and add some pauses in there so you can see what's happening and we can talk through it as we do it. Okay, so that's the first test. We're doing some wraparound checking. Now for the second one, this is identical, except we're going to set the wraparound mode to disabled. Now the rest of the code is the same. Now, when we get to this point where we do the advanced testing techniques, which I've omitted for keeping the code simple, the expectation would be different here. So if we were doing the advanced testing, we could really check those pixels on the left part of the screen, because instead of getting the blue ocean now with wraparound disabled, we would get gray. We would expect to see gray pixels at that point because wraparound is disabled. We'd be past the edge of the visible map at that point. And the rest is the same. Okay, so let's move on to the third test. This is going to be the most complicated test that we cover today. So we're going to do a test where we identify a graphic. So we're going to set everything up from scratch. So we've got our map view, which is set up in the init code. We have a map with a National Geographic base map, set it on the view. We wait for the load status, and now we're going to get the center point of the window. So we get the width in pixels and the height in pixels. We divide them by 2. Now we have the center point of the screen. Now we're going to convert that screen coordinate to a map coordinate with screen to location. Then we're going to set up some graphics overlays and add a graphic to it. We're just going to add a big red square, right in the center of the screen. So we set the graphics overlay up, we add the overlay, we add our new graphic. Now we wait for draw status to be completed. At this point, we're going to hook up to the callback, or in your programming language, it might be an event or a signal. And we're going to make sure that we identified at least one graphic at the center, and we're going to set its selection to true. Again, we have some weights so we can see what's happening. Then we identify the graphic. So we've set up our callback up here, or our signal or event here. We do the identify on the view. After that, we use our handy try compare to just wait for this graphic to become selected. Okay, so let's just briefly run through these tests one more time so we know what we're expecting. In test 1, we expect wraparound mode to be enabled. You'll see it's going to zoom to the side of the map, and we see the wraparound, we should get blue pixels. In the second one, same thing, no wraparound this time. We expect gray pixels because we're beyond the wraparound boundary. In the third one, we're just going to add a big red square to the center of the screen. Then we're going to select it, which we should see the selection halo on it after that. So let's go ahead and run these tests. Okay, so you can see we've zoomed to the extent we have the blue. Everything's blue on the side there. Now wraparound is disabled. Now we have the gray pixels. This is expected. This is correct. And there's our big red square in the center. And now we have that blue selection halo. So it was successfully selected. Okay, I know that went pretty fast. Let's go ahead and just run them one more time so you can see what's happening. Just once more, we have the blue on the side. This is expected with wraparound. Then we do the same thing without wraparound. And this time we should get those gray pixels, and we do. And here's our big red square. There it is. And there's that blue halo for it being selected. So now we know it got selected. Perfect. Okay. And for the sake of speeding things up here, I'm not going to cover the same GUI test in QML, but I do have that logic. All of that logic is here for doing the same exact tests, and I will include that in the project on GitHub. Okay, so let's get back to the PowerPoint here. Okay, so let's talk about some advanced techniques and best practices. Okay, so flaky tests could use an entire talk all for itself. This is a difficult thing to deal with. Flaky tests are typically flaky because they fail at random. and don't reproduce consistently. There are a few different ways to deal with flaky tests. Without getting into the merits of each, here are some possibilities. 1, you could disable them. 2, you could segregate them, move them into their own kind of unreliable test suite. Or another option is even to add some logic into your testing framework to retry them. So for example, if you know a test fails 1 out of every 20 times, then you're probably going to get a successful pass if you allow your test framework to run it maybe up to 5 times. Okay. And flaky tests are a perfect segue to talking about network mocking. So any software that makes network requests is susceptible to network failures. Network mocking alleviates that by capturing network requests and providing the ability to play those recordings back. This allows your test to bypass the network completely and remove that potential point of failure. The more tests you have, the more likely you can be affected by services being down, your ISP cutting out, or any number of random network problems. These can cause noise in your test results. Network mocking can alleviate these types of problems. Examples of network mocking apps are WireMock and Hoverfly. GUI tests have 2 major ways they can work. On the one hand, you can implement them as I demonstrated, which does not do any image comparisons. And specifically, I'm talking about that last graphic selection test where I'm not comparing the image. I'm not doing any image analysis. I'm just programmatically checking that a graphic did become selected by checking properties of the graphic. So at some point, your tests may need to move on to more advanced testing, and that may require image comparison. These can be more difficult to run and to maintain. Now, image comparison tests is another area where I could devote an entire talk. Without getting too heavily into the pros and cons of image comparison tests, I will say that these tests are very powerful. You can have confidence that if your image comparison test passes, you know that that map or that scene looked exactly as you intended. Now, on the other hand, when image comparison tests fail, it is not trivial to determine what went wrong. Here are some reasons a simple web map image comparison test might fail. For example, number 1, the network was down. Number 2, the rendering engine changed and now it looks better. Number 3, the online content, for example, the base map data, was updated with newer information. Number 4, the graphics driver was updated on the test machine and now the results are a few pixels off. Number 5, the baseline test images for the comparisons couldn't be copied to the test machine. Or number 6, there's a real bug in the software. So that's 6 reasons why a test might fail. Only one of them is a real problem. Only one of them is a real problem you need to investigate. The rest of them are just kind of things to be dealt with when it comes with, that's what it comes along with image comparison tests. So what we found is that the key to being successful with image comparison tests is to have a simple workflow to analyze failures and update your expected results. As long as that workflow is smooth, then image comparison tests can be successful for your testing workflows. Okay, let's talk about some best practices. Use good logging messages. Now, at some point, you're going to want to run your tests in automation. That means when a test fails, you're going to want meaningful messages to tell you what happened. You do not want to see things like compare failed on line 50. Avoid shared state. Now, this was covered a bit in the demo, but this is very important as your tests get more advanced. If your test suite has 50 tests and they all rely on a single shared variable like a map, if any test fails and leaves the map in an unknown state, the rest of the test could fail. Each test should be responsible for setting up its own data and preconditions when possible. Tests should be resilient against external factors that you are not testing. For example, if your test requires a base map to display, but you're not specifically testing base maps, the test should be skipped or marked as an expected failure for that test run. If you couldn't set up all the test preconditions, then effectively you did not run the test. Marking that test as failed could lead to misleading results. Keep tests as simple as possible. The more complex a test is, the more points of failure it can have. Complex tests are more prone to breaking and require ongoing maintenance. So here are some references of the Qt test framework I've used in the demos, as well as the network mockers that I mentioned. Here's some more info from other runtime teams and what test frameworks they use, in addition to the Qt ones that I mentioned. So we've got MS Test, JUnit, XCTest, and Espresso are some of the other ones. All of this test code is available on GitHub, even the stuff I didn't demo. And I want to thank you for attending this talk. I hope you got something out of it. Like I said, our intention here is to share what we've learned over the years and the best practices that we've found. So hopefully that you can leverage these to improve your testing or continue your testing efforts and be successful with your apps. Thank you very much.